Hi guys, Miss Griffin. We're looking at Unit 7, Skill 2, and we are going to be talking about solving rational equations. So here is your essential question. How do we solve rational equations? So our process is written over here off to the side, but we want to make sure that we understand what each of these things mean. So a common denominator obviously means that they have the same denominator. And we're going to do this by finding something called the LCD. So first off, turn any whole numbers into fractions by just putting it over 1. And then when I look for an LCD, what we're going to do, oops, I didn't mean to have the big marker, is look at the actual denominator. So right here I have a denominator of x. We haven't placed any denominators up there yet, so we're going to put an x there for sure. This one has a denominator of 3. We don't use that yet, so that's got to go up there. This one has a denominator of 2 times x, but I'm just going to steal the 2 because I already have the x up there. The x was already counted. And then the third one has a denominator of 1. We don't need the 1 up there. Another thing I want you to start getting in the habit of doing is changing this minus sign right here to a plus, and then shifting the negative over to the right. So now our next step is to get those common denominators that we were talking about. So I look at this first fraction and it says 1 over x. So denominator of x is given, but we're missing the blue and the green parts, the 3 and the 2. So I'm going to multiply both the numerator and the denominator by what's missing. So we're multiplying by 3 here, and by 2 on both numerator and denominator. So now what this looks like is we have 1 times 3 times 2 on the top, over 3 times 2 times x on the bottom. Then we have the big plus sign. On the next fraction, this 1/3, we have the 3 from our LCD, but it's missing the 2 and the x. So I'm going to multiply both numerator and denominator by the x, as well as the 2. So now it looks like 1 times 2 times x over 3 times 2 times x. Remember, when you're multiplying, it doesn't matter the order in which you multiply, so it's okay that I've rearranged them. We have equals. On this next fraction, I know it's getting a little messy here, but I have the 2 and I have the x. We are missing the 3. So now I need to multiply numerator and denominator by 3. So now we have equals 3 times 3 all over 3 times 2 times x. We change this minus to a plus. And then we have, let's see, a denominator of just 1. So it's missing all 3 parts. Notice how it doesn't have any of those colors. All 3 parts need to be multiplied. So we're going to multiply top and bottom by x, top and bottom by 3, and top and bottom by 2. So now it's plus negative 1 times x times 3 times 2 all over 3 times 2 times x. And you'll notice that each one of these denominators is exactly the same, and that was the whole purpose because now we can drop them. Now that they're identical to one another, we can drop them and just start multiplying, combining like terms, and solving for x. So here we have 1 times 3 times 2, which is just 6, plus 1 times 2 times x, which is 2x, equals 3 times 3, which is 9. And then on the far right, we have negative 1 times x times 3 times 2. So this makes 6 times negative 1 makes a negative 6. Attach the x. And from here, we're just solving. So I'm going to consider adding 6x so that they cancel, subtract the 6 so that they cancel, and now we have 8x equals 3. Get rid of the 8 by division. So now we have x equals 3/8. And what I do is look back to check my answers. This is super important. We're going to write a little note about this. In order to check your answers, we need to plug x value back into the original denominators to see if it equals 0. And if it does, we reject. So I look way back up top to those original denominators of x, 3, 2x, and 1. And if I were to take my 3/8 x and plug it into any of these denominators here, does it equal out to 0? And the answer here is no, because x right here, oops, still got the big marker, x right here is just x and 3/8 is not 0. This is a 3, so I can't do any plugging in there. 2 times 3/8 is not 0, and then I can't plug into this one spot. So this means this is a good solution. We can keep it. All right, moving on to example 2. We have 2 over x plus 5 plus 20 over x squared minus 25. So we're going to take this denominator and actually factor it. You should recognize that this factors very quickly and easily into x plus 5 and x minus 5. And then also turn this 1 on the right-hand side over 1 into a fraction. So for our LCD, lowest common denominator, or least common denominator, however you prefer to say it, I look at the first fraction and I see x plus 5. So I'm going to put that in parentheses because it's a whole entire expression. I can't separate it. Whereas in this 2x up here, I was allowed to separate it because it was multiplication. This one's addition, and same with subtraction, you're not allowed to separate. All right, so then when I look at the second one, I already have x plus 5, so I don't need to worry about that. But I do need to worry about x minus 5. That's not up there yet. And then the third one is just the 1, so I can kind of ignore that for the time being. So when I go to figure out what to multiply by, this first fraction has the red piece, the x plus 5, but it doesn't have x minus 5. So on the top and bottom, it needs to be multiplied. So now we have 2 times x minus 5 all over x minus 5 times x plus 5. Then we have plus, the second fraction actually has both pieces. It has the blue and it has the red. So this second fraction is perfect just the way that it is. Equals, now this third one only has a 1. So it needs to be multiplied by x minus 5 on top and bottom, and x plus 5. So now it's 1 times x minus 5 times x plus 5, all divided by 1 times x minus 5 and x plus 5. All right, so common denominators drop away. We're going to start distributing just so that we can make this process a little faster. And then we'll solve for x. All right, so when I combine like terms on the right-hand side, those cancel. Now we have 2x plus 10 when I combine these here, equals x squared minus 25. So because of this x squared here, we have to get this side equal to 0. So I'm going to subtract 2x and subtract 10. So now we have 0 equals x squared minus 2x, and then negative 25 and negative 10 make negative 35. And from here, you should be recognizing that to solve this, we need to add multiply. So we have 0 equals, parentheses, on both parts, x times x will multiply to make x squared, and then 7 and 2 will multiply to negative 35 and add to a negative 2 by subtracting, oops, not 7 and 2, I'm sorry, 7 and 5, by subtracting the 7 and adding the 5. So then we t-chart and we get x equals opposite sign every time. So x equals 7 and x equals negative 5. But then don't forget that we do need to take these numbers and plug them back into our original denominators to do that check. We want to check to see if it's equal to 0. And if it is, then remember that we need to reject it. So if I plug in 7, we have 7 plus 5. 7 plus 5 is 12. I keep using that marker, which is clearly not 0, so then we're good. Let's see, 7 squared minus 25 would be 49 minus 25, which is not equal to 0. So we can definitely keep this answer. If I try negative 5, however, if we do negative 5 plus 5, and I'm just plugging into that first denominator, this does give us 0. So then I immediately have to reject it. I don't even have to check it on the other ones. As soon as it doesn't work out for 1, then I have to reject it. So our one and only answer should be x equals 7. All right, example 3, we want to factor first, so we should be add multiplying for this one. It would be a minus 6 and a minus 3 in order to add to negative 6 and multiply to 18. So our LCD over here, remember, start on the far left. We haven't used a minus 6 yet, so we need it. We haven't used a minus 3 yet, so we need it. But then on the second denominator right here, we already have a minus 6, so we don't need to write it a second time. On this one, we already have a minus 3, so we don't need to write that a second time. Okay, so we're done with that part. I notice that there's a minus sign in here, so I'm going to change it to a plus and drag the negative to the second fraction. Right, so the fraction that's behind it gets the negative. And so now we go through our process. This denominator already has both terms, so I don't need to touch that fraction. So I'm just going to actually rewrite it the way that it is. And then we have equals. This second denominator only has a minus 6, so it needs a minus 3, which means the top also needs a minus 3. So now we have 2 times a minus 3 all over a minus 6 times a minus 3. And then lastly, this last denominator only has a minus 3 and it needs a minus 6. So then it's plus a negative 4 times a minus 6 all over a minus 6 times a minus 3. Now that the denominators are completely the same, we cross them off and we keep going. 3 equals, I'm going to distribute here, so 2a minus 6, and then negative 4a plus 24. 3 equals, combine some like terms, so negative 2a plus 18. I'm going to subtract 18 from both sides. So we have negative 15 equals negative 2a. If I divide by negative 2 to solve, then we get a equals 15 over 2, or a equals 7.5. Since it's a terminating decimal, I can actually use it. And then again, we have to check. So if I go back to my original denominators, here, here, and here, if I were to plug in a equals 7.5, I recognize that it's never 0, so I can actually box this in. This is my answer. All right, example 4. So again, we want to look for factoring. This third one can be factored. Take out a common denominator, or a common factor of x, and then we're left with x plus 2. So LCD, start on the far left. We have not yet taken x plus 2, so we're going to use it with parentheses. We have not yet taken just a single x. Okay, and then we have taken already the single x, and we have taken already the x plus 2. Okay, so can you guys see how we're not using it a second time? All right, so this first fraction has an x plus 2, but it's missing the x. So now we have x times x over x times x plus 2. And then it's equal to, okay, let's see. This has the x, but it's missing the x plus 2 on top and bottom, because whatever you do to the top, you have to do to the bottom. So now it's equal to 3 times x plus 2 all over x times x plus 2. And then we have plus 4. This denominator already had both parts, so we don't need to change it at all. We just want to keep it in its factored form so we can see that, oh, hey, all the denominators are the same, so they get crossed off. And then from here, we're solving. So we have x times x is x squared equals, distribute here, 3x plus 6 plus 4. So x squared equals 3x plus 10, just combining like terms. And then because of this x squared, we want to move these terms to the other side, get it equal to 0. X squared minus 3x minus 10 equals 0. And so then from here, we're just thinking again about factoring. So we have a, m, add, multiply, x and x for our parentheses. multiplying to 10, we have 1 and 10, or 2 and 5. 2 and 5 is the pair that will add to -3. So we have 5 with a 2. Bigger number, 5, takes the sign of that middle term. So -5, and then to multiply to a negative, we have to have opposite signs, and so then this must be positive. When we t-chart, we end up with x equals +5 and x equals -2. But remember that we have to take it and go back to that original denominator, or set of denominators, and see when we plug in each of these values, would we get 0? So if I plug in 5 into that first denominator as 5 plus 2, which is clearly not 0. 5 plus 2 is 7. If I plug it into the second denominator, we just have 5, which is also not 0. If we plug it into the third, we have 5 squared plus 2 times 5, which is also not 0. However, if I check the -2, we would have -2 plus 2, which is 0. So I have to immediately reject the -2 and only keep the 5. And again, this was because I was plugging into the denominators. All right, flip it over. We have one more question. So on this last page, it says solve for s in terms of r and t. So none of these denominators are exactly the same. So when I start my LCD, we definitely need to have an r. We also need to have an s, and we need to have a t. So then when I start multiplying, I recognize that this first fraction with 1 over r needs to be multiplied by s on the top and bottom, as well as by t on the top and bottom. So now it's 1 times s times t over rst. Then if you see, we've got this little negative here. We want to add the opposite. So what that's doing is adding instead of subtracting, and then swing the negative to the fraction on the right. We call that add the opposite. So now we have a -1 times whatever it gets multiplied by. So this second fraction has the blue term with s. We're missing the red and green, so we need r and t. So multiply by r on the bottom and on the top, multiply by t on the bottom and the top. Whatever you do to the bottom, you have to do to the top. So it's -1 times r times t all over, oh, and this has a big plus sign here, all over r times s times t. Still equal to 1 times something. So now this third fraction has the t, the green term, but it's missing red and blue. It's missing r and s. So when I look over here, we have to multiply top and bottom by r, multiply top and bottom by s, and then we'll have common denominators. So this is 1 times r times s over r times s times t. These denominators are all exactly the same, so they cancel. So now we have 1 times st, which is just st, plus -1 times rt, so that's really negative rt, equals 1 times rs, which is just rs. And because, remember, our goal is to solve for s, what we're going to do is get all the s terms on one side. So I'm going to choose to subtract this rs. And then I also need to add this rt, because this rt does not have an s in it, and so it's got to move. So now we have st minus rs equals rt. And again, we're trying to solve for s. So I can notice that there's an s in both of these terms. So I take an s out as a GCF, and we're left with t minus r equals rt. And to continue solving for s, we're going to get s alone by dividing both sides by t minus r. So now we have s equals rt over t minus r. And that's all that we can do here, because all it asked for us to do was solve for s. All right, so don't forget to write your little summary down here at the bottom. Ooh, I meant to highlight, not cross through. Write your summary and then move on to your practice problems next class. Let us know if you have any questions. Otherwise, good luck.